Two spherical conductors B and C, equal radii and carrying equal charges in them, repel each other with a force F when kept apart at some distance. Okay. A third spherical conductor having same radius as that of B but uncharged is brought in contact with B, then brought in contact with C, and finally removed away from both. The new force of repulsion between B and C will be what? Okay. So let me be very clear that let's say this is our spherical conductor initially B. Okay, this is our B and this is our spherical conductor C. Question says they both have equal radii. Okay, both are in same size and carrying equal charges. So let's just take an example that this charge on B is Q and charge on C is also Q. Then what is the force between B and C? The force should be, by Coulomb's law, it should be K Q1 Q2 upon separation R square. Okay, let's assume that the separation between both of them is R. Now this is our initial force, so let's call it as F naught. Okay, great. Now it is saying, and this F naught is FO. So the question itself is saying the force is F. So let me make it here F only. Question says a third spherical conductor having same radii as that of B but uncharged. So what is the initial charge on the third one? It is 0. Correct? Okay, uncharged is brought in contact with B and then brought in contact with C and then finally removed. So let's touch it. Let's touch this as let's call it as A, any A, and let's touch it with B. So when you touch it with B, what is the new charge on A? The new charge on A will be equals to Q plus 0 by 2. Why Q plus 0 by 2? Q is the charge on B, 0 is the charge on A. Add both of them and divide it by 2 when you touch them. So it will give you Q by 2. And what is the new charge on C? Oh, sorry, B. This is also Q by 2. Okay. So charge on A and charge on B, both is Q by 2. Now if you touch this A to C, what will be the new charge on C and A? So let's see the second time when you touch, let's call it as A double dash. Okay, let's call this as A dash and B dash after the first touch. The second touch, A double dash, will be equal to how much? The charge on C plus the new charge on A, which is now already Q by 2. So Q by 2 whole divided by 2. So this will become Q by 2, this will become how much? 3Q by 4. When you will simplify, you will get 3Q by 4 and final charge on C will be C double dash, which is equal to how much? 3Q by 4. Great. Let's read the last part of the question once again. The question says the new force of repulsion between B and C we have to find. So let's ignore this A. Let's focus on the final charge on C. The final charge on C is 3Q by 4. The final charge on B is Q by 2. Let's put it back, okay, in our Coulomb's law. So the new force will be, let's call it as F dash, and that will be equals to K, the charge on, new charge on B, Q by 2, the new charge on C, that is 3Q by 4, whole divided by same separation, as they have not mentioned if we have to change the new distance, the separation will still remain same. So this will give you 3 by 8, okay, when you will multiply 3 by 8 K Q1 Q2, which is KQ square by R square. Okay. So initial force will be F equals to K Q1, which is Q, and Q2, which is also Q, upon R square. So if initial force is this, the new force, which is F dash, we get equal to 3 by 8 of the initial force, which is our F. Okay. So the correct answer is 3 by 8. Okay. So 3 by 8 will be our new answer. So option D should be the correct, which is none. Okay. So none means 3 by 8 it should be.